Hey you guys, and welcome back to yet another video. In this video, we're going to be going through standard 4.NF.3c, and this is actually going to be a series of videos covering this one standard. In this particular video, we're going to be estimating the sums and differences using benchmark numbers, and this is coming straight to you from Module 5, Lesson 29. So scholars, I want us to look at this anchor chart and become familiar with it because we're going to be using this a lot in our video as well as in our lesson. So we're going to be following these steps. There's 5 steps, 1 through 5, that we are going to use in order to add and subtract mixed numbers using benchmark numbers. And what I mean by benchmark numbers is like 1/2, 0, 1, 3, 7. Really, any number that falls on the number line that's easy to identify, we call those benchmark numbers. And scholars, we're going to be converting to a mixed number if necessary, drawing 2 number lines, plotting mixed numbers on the number line, circling the closest, that's the buzzword, closest benchmark, and then we're going to add and subtract the circled numbers. Let's get right into our lesson for today. So in this first problem, I have 3 1/5 plus 4 8/9. Scholars, I know that there's no point in us doing step 1 only because we don't have to convert to a mixed number. The work has already been done for us. Now it's just time for us to draw our number lines. So I have 2 number lines, and this first number line is going to represent the mixed number 3 1/5, and the second number line is going to represent the mixed number 4 8/9. Now scholars, I know that in 3 1/5, it's between 3 and 4, so my number line is going to end at 4. 4 8/9 is between 4 and 5, so my number line is going to end at 5. Now just fill in the rest of your number line. Awesome, you guys. So now that we have our number lines filled in, it is now time for us to determine where we're going to plot our mixed number. Now, scholars, I know that 3 1/5 is between 3 and 4, so I'm looking right here in this space. And I'm actually going to be decomposing this space into fifths because my fraction is in fifths. So 1/5, 2/5, 3/5, 4/5, and this 5/5 actually represents the 4 or 1 whole. 3 1/5 is right here. So 3 1/5 is actually closest to the benchmark number 3. Let's do the same thing to 4 8/9. So I'm looking between 4 and 5, and I'm decomposing this space right here into ninths. So 1/9, 2/9, 3/9, 4/9, 5/9, 6/9, 7/9, 8/9, and then 9/9 would represent that 1 whole or 5. 8/9, 4 8/9 falls right here, which is closest to the benchmark 5. So now instead of saying 3 1/5 plus 4 8/9, I could just say 3 plus 5 because I was able to estimate using my benchmark fractions, and I get 8. Let's do another one. In this problem, I have 8 9/10 plus 2 4/8. So again, there's no need to convert because I don't have any improper fractions. Let's get right into our number lines. So again, I'm labeling my number lines so that I don't get confused about which mixed number is represented by which number line. And now I'm going to go ahead and ask myself, how would I fill out my first number line? 8 9/10 is between 8 and 9, so I know my number line is going to go all the way to 9. However, I wouldn't go to 0. I wouldn't put 0 here only because I would be here forever plotting that. So I can actually just put 8 there. And I know halfway between 8 and 9 is 8 1/2. But I'm in tenths, so I know that it would actually be 8 5/10. Now I'm going to go ahead and fill in my number line until I can figure out where I'm going to put 8 9/10. Well, this is 8 5/10, 8 6/10, 8 and 7 tenths, 8 and 8 tenths, 8 and 9 tenths, 8 and 10 tenths. So 8 and 9 tenths is right here. I know that 8 and 9 tenths is closer to 9 than it is to 8, and it's closer to 9 than it is to 8.5. So I know that I'm going to be circling 9. Let's do the same thing for 2 and 4/8. So for 2 and 4/8, it makes sense for me to start at 0. And I'm actually going to be going all the way up to 3 because 2 and 4/8 is between 2 and 3. All right, you guys. So I'm decomposing this space right here into eighths. So 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and then that's 8/8. 4/8 is right here, smack dab in the middle. Scholars, I know that the distance between here and here are equal. So I know that 2 and 4/8 is just the same thing as saying 2.5. So my benchmark for 2 and 4/8 is 2.5. Now I'm just going to add them together. 9 plus 2, 11. Bring over my half. So 8 and 9 tenths plus 2 and 4/8 is about 11.5. Let's do one more. This time we're actually going to need to convert because we have improper fractions. So I have 15/4 and 22/7. Now, scholars, I know that I can pull out 12/4 because 4 times 3 is 12, which means I would be left with 3/4. Same thing for 22/7. I can pull out 21/7 because 7 times 3 is 21, and then I will be left with 1/7. So 15/4, if I go ahead and draw those number lines, 15/4 is the same thing as saying 3 3/4. And 22/7 is the same thing as saying 3 1/7. So in both of these, I'm going to go all the way to 4 and fill in the rest of my number line. Now that my number line's filled in, it is time for me to plot where my mixed numbers are going to go on my number line. So I'm looking between 3 and 4, looking between 3 and 4. I know that I'm decomposing this space into fourths, so 1/4, 2/4, 3/4, 4/4, and 3 3/4 is right here. 3 3/4 is actually closest to 2 benchmark fractions or numbers. It's close to, or is 1/4 away from 4 wholes, but it's also 1/4 away from a half. So it really doesn't matter here which one you choose. However, I always like to round up, so I'm going to be rounding this to, or estimating to, 4 wholes. Now I have 3 1/7. So I'm between 3 and 4, and I'm decomposing this space into sevenths. 1/7, 2/7, 3/7, 4/7, 5/7, 6/7, 7/7. And 3 1/7 is right here. 3 1/7 is very clearly closest to the benchmark 3 wholes. So looking back at my original problem, I'm subtracting. So I'm subtracting 4 minus 3, which leaves me with 1. So 15/4 minus 22/7 is about 1 whole. Scholars, I want you to try this last problem on your own using what you know about benchmark fractions and the information you learned in this video on a piece of paper. So I want you to solve this problem. 2 2/6 plus 3 4/5. Make sure you are estimating to the closest benchmark fraction.